The way you solve inverse variation is similar to direct variation, with the exception of the formula you're going to start with. So if I say that x is inversely proportional to y, then I have to write it as x inversely proportional, so we reciprocate the value. And as direct variation, I could replace this proportionality, this inverse proportion symbol, with a constant, and the constant is k. If you're more comfortable, you can write it separately as k times 1 over y. So we're going to follow the same procedure as we did in direct variation. And I'm going to go through two algebraic examples and one worded example. So we have that q varies inversely as r, so we already have this relationship. And if q is given equal to 5, r equals to 2, I need to calculate the value of r and q at specific values. So don't use ratios, don't use just dividing and multiplying each value, because there's a constant k that we have to be aware of. So let's find this constant k and then we can deal with these. So that's what you always have to do. So q would be equal to a k over r, and we substitute the values they gave us. So I have 5 equals to k over 2. I cross multiply, I'm going to get k is equal to 10. So now I can use q equals to 10 over r as my formula. And then I can easily find a. So if I need to find q when r is equal to 4, I just have 10 divided by 4, and I could just simplify this fraction, divide by 2 on both sides. So I'm going to, on numerator denominator, so I'm going to get 5 over 2. You can leave it as such or as a mixed number. For part B, I need to find r when q is equal to 20, so I just write 20, and then 10 over r. I cross multiply as well, so I get 20r equals to 10, and so r equals to 10 over 20, which is 1 over 2. So you can always check your answers by substituting back in any other way possible. So either you substitute both values to get the same k, or so on. So this is how you do it with algebraic numbers. This example, it's a bit of a challenging question, but I do want to go through it just so that you're comfortable with all this algebraic behavior. So what this is actually telling you is that y is inversely proportional to the nth root of v. And they've already given the formula with a k in there. But n is missing and k is missing, and that's what we need to find, and only when we find it can we actually complete the table. So when you have two values missing, you need two given values to be able to find these unknowns. So we're going to start and substitute n just to see what happens and see how we can find the k and the n. So we substitute this first set of values, 1 and 12. So we have 12 equals to k over the nth root of 1, because v is 1. But note here that the nth root of 1 is always 1. If you take the square root of 1, the cube root of 1, the 100th root of 1, they will all be just equal to 1. So this is just k over 1, which means that k is equal to 12. So it's actually much easier once you've gone through an example. So let's try, and now that we have k, we can actually easily find n. So we have 6 equals to 12 over the nth root of 4. We can cross multiply and get 6 times the nth root of 4 equals to 12. And we divide by 6 on both sides, so we get 2. And it's very obvious that the only root of 4 that would give you a 2 is if n is equal to 2. So quite straightforward to do. So k is equal to 12, and n is equal to 2. When it comes to things like the nth root or the nth power, for this level, for an IG level, they wouldn't actually give you something too complicated. So you would eventually be able to find it. There's no simultaneous or anything that you'd have to do. So now that you have the values, you can actually find 36. The y, if v is equal to 36, you can try the substitution on your own. The answer here is going to be 2. And you can then substitute the 3 over 25 and so on, and you're going to get a 10,000. So just an odd example that I wanted to try this video. So the last example would be this worded problem. So we have a volume given and it varies inversely with the pressure. So volume varies inversely with pressure. And they've given us two values, which means I can use them to find the constant K. And using this, I need to first find the volume and then I need to find the pressure. So I have two things that I need to do. So first, let me find the K. And just be careful here that it doesn't say the square root of pressure or the square of pressure or anything, so it's just pressure. And then we substitute values in, and this will give us, we cross multiply, so we have K equals to 1,000. So for the volume, I have the pressure is 400, and I have my 1,000 here, so 1,000 divided by my 400 is going to give me 5 over 2. But because we are dealing with actual things, so do write it as a decimal, and be careful with the units. It's volume, and your volume is given in meter cubed. Okay, so for pressure, we have that the volume is 5, we have our K, we have our pressure is unknown, cross multiply, and we're going to get P is equal to 1,000 divided by 5, and that's going to be 200. Using the units, we have Newton per meter square. So hopefully these examples were clear, quite similar to direct proportion. So just be comfortable with the first step, which is finding K, and then the rest is going to follow.